Hi, this is Grandpa Bob. At a family reunion, he brings 10 $1 bills to give to his 3 grandchildren, Ruby, Violet, and Clementine. But 10 doesn't divide into 3 evenly. Oh, Bob. It's okay, though. We can't all be perfect like the way Beth Harmon was at chess. So how many ways can Bob distribute his money? He could give Ruby $3, Violet $3, and Clementine $4, or any variation of this changing who gets the $4. But say he liked little Clementine a smidge more than the other two. He could split up his money like this, or even like this. There are certainly many ways to split the money, and our goal is to count them all. Let's visualize the problem. The circles represent the dollar bills, and the lines are dividers. With 2 dividers, we get 3 partitioned areas. The first will be Ruby's amount, the second is Violet's, and the third is Clementine's. In this scenario, R gets $2, V gets $3, and C gets $5. And then this would mean R gets $1, V gets $0, and C gets $9. Let's take away the circles and lines. We have 12 slots. In order to count the number of ways for Bob to distribute his money, we need to find the number of ways to pick 2 slots for the dividers, because once we have the 2 dividers, the rest of the slots will all be dollar bills. Every arrangement of the 2 dividers will account for 1 possible way for Bob to divide the money. The first divider has 12 options of which slot it will go in, and the second has 11. Multiply and we get 132 ways. Yay! No, take off your party hat, Bob, because this is not the end yet. These dividers are indistinguishable. What does that mean? Well, let's check it out. Let's make them distinguishable first. This one will be Frankenstein the monster, while this one is Frankenstein the scientist. Turns out, it doesn't matter to us if it's the monster or the scientist at each position. Ruby always gets the first part, Violet always gets the second, and Clementine always gets the last. Whether these Frankensteins are arranged like this or like this, we get the same outcome. This means that the 132 is double the correct answer because we counted every possible way twice. So to get the correct answer, we divide by 2. Congratulations, Bob. We found that there are 66 ways for you to divvy up your money to your 3 grandchildren. The formal notation for picking 2 slots out of 12 is 12 choose 2. This is called a combination. The general formula of n choose k is n factorial divided by n minus k factorial times k factorial. This matches what we found. 12 times 11 is 12 factorial divided by 10 factorial. 2 is 2 factorial. If you enjoyed this problem, there is much more in Combinatorics for you to explore. Combinatorics is a branch of mathematics all about counting. Today, we use the sticks and stones technique for the scenario of indistinguishable bills and distinguishable children, which is one of Richard Stanley's 12-fold way. Some of the other ways lead to Stirling numbers of the second kind, and partitions, and lots of interesting stuff. So join Grandpa Bob next time for another adventure in mathematics.